Electric charge. First, electric charge is conserved. An isolated object charge cannot be created or destroyed. There is a fundamental charge, that is the charge that is had by a proton or an electron, the proton being positive, electron negative. In nature, the total amount of charge of an object is an integer multiple of the fundamental charge. And that fundamental charge is approximately 1.6 times 10 to the minus 19 coulombs. Another fact is that some materials are conductors and others are not, insulators. For a conductor in electrostatics, any net charge must reside on that conductor's surfaces. Now, charge comes in a number of flavors, right? We'll have the point charge Q, and we can have a number of charge densities, a line charge lambda. Lambda is charge per length. We can have a surface charge density, so sigma is a charge per area. And we can have the usual density that you're familiar with, a volume density, but here it's a charge per volume, not a mass per volume. Now, an example of charge conservation would be, we have an isolated object that has 10 coulombs. We split it up into two pieces, and we can actually get a piece with more than 10 coulombs, 18 coulombs, but the other piece then has to be minus 8 coulombs, so that the minus 8 plus the 18 adds up to the 10, right? So charge is conserved, but it may seem like we can, from even zero, like if we had something with no charge, we could split that up into two pieces and get a positive and negative amount that add up to zero. Now, just to look at some calculations with densities. So this is the point of net electrostatic charge on a conductor resides on the surface. I have two almost identical, they're identical in terms of geometry, solid spheres, radius 8 centimeters, 0.08 meters, charge 2 coulombs. And here I've calculated the surface area of the sphere, 4 pi r squared, and the volume, 4/3 pi r cubed, right? So I have area and volume in square meters and cubic meters. Now, for the only difference is this sphere is conducting and the other one is non-conducting. So for the conducting sphere, any charge that would have been anywhere in this volume must spread out on the surface. And assuming a uniform density, we would get sigma, the surface charge density, to be this 2.49 times 10 to the 1 coulombs per square meter. And rho, the volume density, is 0 because all the charge is on the surface. But in the non-conducting case, assuming the charge is spread out evenly, we would have a volume density, rho, 9.33 times 10 to the 2 coulombs per cubic meter, and there would be no surface density, right? All of the charge is happily residing in the volume with no problem, right? But in the conducting case, charge in the volume immediately runs to the surface. And so these basics of charge conservation, the fundamental charge, that the fact that in electrostatics, in the case of conductors, charges, they move to the surface and stay on the surface. And the calculations that deal with point charges and the various densities, whether it be a linear density, surface density, volume density. These are some of the basics we'll be needing as we get into the electrostatics theory.